Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to discuss about the application of titration in volumetric analysis. So, this is my group mates, which is myself, Hairul Fakri, Mir Muhammad Zakri, Muhaizatul Aisyah, Ainun Najwa, and also Nur Alia. So, the content of this video will be going to separated by 7 parts, which is the first part is the introduction of the volumetric analysis, the principle of volumetric analysis, the classification, methodology, example of result, application of titrations, and also the last is conclusion. Moving to the first part of this video, which is the introduction for volumetric analysis. So, what is volumetric analysis? Volumetric analysis, also known as titration, is a method that has been used in a laboratory to determine the concentration or amount of a substance which is analyzed in a sample solution. It involves measuring the volume of a reagent, which called as titrant, of known concentration required to react completely with the analyte. Moving to the next part, which is the principle of volumetric analysis. The first principle is the solution concentrations which needs to determine is unknown. Second, to determine the volumes of the reagent or solutions, titration will be performed. Thirdly, using titration, you may figure out how much of a solution called titrate is in a volumetric flask and how much reagent or titrations is in a burette. Fourth, the presence of an indicator indicates that the interaction between the titrant and the titrate has vanished. For example, we are using such as methyl orange or phenolphthalein as an indicator to show whether the titration reaction is completed by changes of color. And the fifth principle is the amount of titrant and titrate are measured with the help of the volume and concentration of the reagent employed in the titration.
Let's see the type of titration. First, we have acid-base titration. This titration is based on the reaction that called neutralization between an acid or base and the analyte. Secondly is complexometric titration. This type of titration is widely used to determine the number of metal ions involved in the reaction. The third one is redox titration. This titration involves the transfer of electrons take place in the reacting ions of the solution. And the last one is precipitation titration that forms an insoluble precipitate when two reacting substances are brought into contact. These two reacting substances are typically a soluble reactant and a precipitating agent. Let's move on to the methodology of acid-base titration. The first step is we have to prepare the solutions needed for the titration. This includes the analyte solution, the solution containing the unknown concentration of the acid or base, and the titrant solution, a solution of a known concentration of the acid or base. Both solutions should be carefully prepared and accurately measured. Then, set up the titration apparatus, which typically includes a burette clamp, burette, redox stand, pipette, and a conical flask for the analyte solution, and a suitable indicator if necessary. Ensure that the equipment is clean and free from any contamination. Next, measure a fixed volume of the analyte solution into the flask or a beaker using a pipette or a volumetric flask. An indicator is required. We have to select an appropriate one based on the expected pH range of the titration and the acid-base properties of the analyte and titrant. Add a few drops of the indicator to the analyte solution. 2 to 3 drops should be enough. And begin the titration by slowly adding the titrant solution from the burette into the analyte solution while continuously swirling or stirring the mixture. The titrant should be added dropwise near the endpoint to ensure precision. Observe for any visible changes in the solution as the titrant is added. This may include a color change if an indicator is used or a change in another observable property. The endpoint is the point at which the reaction between the analyte and the titrant is complete. Most importantly, record the final volume of the titrant solution in the burette. This volume is required to calculate the amount or concentration of the analyte. Then, perform the titration multiple times to ensure consistency and accuracy of results. Use the recorded volumes and the known concentration of the titrant to calculate the concentration or amount of the analyte in the original solution. This calculation is based on the stoichiometry of the balanced chemical equation for the acid-base reaction. Lastly, dispose of the solutions properly and clean the equipment thoroughly to prevent contamination for subsequent titrations.
Now we are going to see the example of result in titration. Referring to the table below, we can see the titration of HCl and sodium hydroxide to determine the exact molarity of HCl and sodium hydroxide. To conduct the experiment, we need to record the initial burette reading in order to determine the volume of sodium hydroxide used throughout the titration process. The titration process has been done 3 times to ensure the accuracy and the volume of sodium hydroxide used. To calculate the exact molarity of sodium hydroxide, we are using the MAVA and MBVB formula. The A1 is HCl and the B1 is sodium hydroxide. Then we just calculate like the usual and like the shown, and the answer is 0.098 mole. Next, we are going to see the application of titration in education. Titration allows students to observe chemical reaction in action. By visually analyzing the reaction, they can learn about formation of precipitation, color changes, and other indicators of reaction progress. During titration experiment, students can practice applying stoichiometric principles. They learn to balance chemical equations, figure out the moles ratio of reactants and products, and figure out how many different substances are involved in the reaction. Titration experiment enhance students' analytical skills. They learn to measure volumes. They learn to measure volume accurately using burettes and pipettes, and handle the solution properly and follow the precise procedure.
Next, we have the application of titration in manufacturing. First, we have the food and beverage industry that makes extensive use of titration for quality control. It assists in determining parameters like acidity, salt content, vitamin concentration, and additive presence. For instance, titration is used to measure the titratable acidity of dairy products, wine, or fruit juices to make sure they meet the requirements. Additionally, it is used also to evaluate the efficacy of food storage and processing sanitizers. Next, we have the petrochemical industry. In this industry, titration is used to measure the concentration of salts, acids, bases, and other components in a variety of petroleum products. It assists in determining the quality of lubricants and fuels, the concentration of sulfur compounds, or the acidity of crude oil. Next, we have the pharmaceutical industry. In the pharmaceutical formulations, titration is used to determine the concentration and purity of APIs. This helps make sure that the amount of active ingredient listed on the label is correct in the medication. Acid-base titrations, redox titrations, and complexometric titrations are all common titration techniques utilized in the API assay. To conclude, volumetric analysis is such a vital technique for determining substance concentrations accurately, and we can see that these techniques are applied in food and beverages industry, petrochemicals industry, pharmaceuticals industry, and education industries. There are many types of titration that we have learned, such as acid-base titration, complexometric titration, redox titration, precipitation titration, And what are the importance? So the importance are making informed decisions, to ensure product quality, and also to make sure it is comply with any rules and regulations that exist.